Okay, so you've already made your decision, right, of who you thought traveled further, okay? And then you watched a video for the other side of the argument, okay? Whatever you chose, you watched the alternate video to your choice, okay? So you've already also done how does this show that there's sort of two definitions to how far something can travel, okay? So one way, which we would say is the Dorothy way, right? Dorothy wins if we measure start to finish, like on a ruler or a straight line. Okay, so if you didn't watch the Dorothy video, if you chose Dorothy, you could also go back and watch it, right? But basically, if we laid out a ruler here, right, Dorothy went from here to here, this far. Toto only went from here to here. So look, Toto didn't go nearly as far as Dorothy. Dorothy went way further than Toto. Okay, that's one way to describe how far something travels. Okay, this we call displacement, which we'll do a definition for in a minute. Okay, this would be called a displacement. This is a straight line measurement of a changing position. Okay, if you chose Toto, you know, you could also make the argument that Toto went further. Let's use a different color for Toto. Okay, the Toto way is actually feet on the ground, right? So Dorothy, right, only actually went that far, step, right? But Toto, step. Toto took a lot more steps. Toto had more feet on the ground steps than Dorothy did, okay? So that would mean that Toto actually went further than Dorothy, all right? So for the Toto way of measuring it, like feet to ground, we call that distance, okay? In physics, those two are very, very different things, all right? We are going to be more concerned with, well, not totally, but displacement is a little more important to us in physics, although we will talk about distance, okay? So displacement is simply a start to finish, right? It's like, I saw you here, don't care what happened, now I see you there, that's how far you went, right? Displacement doesn't really care what happened in the middle. Distance does care about that. Distance wants to know how many times your feet hit the ground, okay? So that would be distance, all right? Okay, so when we're thinking about these things, so let's go ahead, you're going to fill this out. These three words are very, very important moving forward, okay? So position is the location on the ruler, okay? So this would be I am at 10 meters. Right? Or I am at -5 feet or something, right? So position would be like there would be some ruler, right? And, your little car or whatever would be sitting at a certain position. You read this number off, 1 meter, that's my position. It's a location. It's like a snapshot. It's like a snapshot or like a picture. Okay, one instant in time where I'm at is position, okay? Distance is actually, we like to say path length is good, or feet to ground, or it could be wheels to ground, whatever, right? But distance is actually the total amount that you covered, right? The total amount that you walked, boom, boom. Right? Distance does care about all the little wiggles and up and down and up and down. That counts for distance. Every time your feet hit the ground or the tires make another rotation on the ground, that counts for distance, whether you're going back and forth, right? So like if I was going from here to here, say I'm going from home to the store, and I go there and back, right? That would be, say it's like 10 meters away. I went 10 meters there, I went 10 meters home. That means I went a distance of 20 meters. Right? Because I actually stepped on the ground covering 20 meters. Okay? Displacement, however, is the change in position. Okay? And it'll be a little hard unless you're writing. You might be able to just write it with your mouse. It's called delta. Okay? I don't think ClassKit can make the delta. It's a little triangle. Okay? Delta X, position we would call X. okay? We'll get into that later, actually, okay? Change in position. So this is only start to finish, right? I don't really care about the middle. I just care about how far you are from where you started, okay? So back to this example, home and school, or the store, right? If it's 10 meters there and 10 meters home, my displacement is 0. I didn't go anywhere. I started at home and I ended at home. That means technically I went nowhere. Okay, so in physics, we would say, nope, who cares? I don't care if you went like 50 miles. Doesn't matter. 100,000 miles, don't care. You're back in your starting place. Your displacement is 0. Okay, we're going to do a lot more with this stuff, but just so you kind of get the idea of what these 3 terms mean, okay, especially position, all right, because this is one thing you're going to need going forward in the lab. Well, actually kind of all of them, okay? And if you're talking about something moving in a straight line, distance and displacement, it kind of doesn't really have a difference, right? If I'm only going from, let's say I go from like here to here, right? And it's a straight line, one-way path, then it doesn't really make a difference, okay? It's only when you start turning around and going back, or you make some other wiggly path, that it makes a difference. All right? Okay, so the last part of this, after this video, is you're going to do sort of the lab for this week.